Today, I'm going to do for you an internal webinar with the title of the best practices to design Automation Studio application for OPC integration. This is my second webinar on the subject of OPC. And in this webinar, I want to elaborate more and be more specific to give you good way of applying things to make an Automation Studio application very easy to integrate in OPC. So I'm just going to go very fast over the agenda, what we're going to be covering. So basically, we're going to build an Automation Studio application, and then we're going to have defined the input and the output in to be used for the PLC ladder logic program. Then we'll be downloading the application to the PLC, and then we configure the OPC server and then test the OPC configuration. And then after that, we'll connect Automation Studio input and output variable to the PLC input and output register, and then we'll be testing the ladder logic with the Automation Studio application. But by the end, I'll be accepting all your, we'll open the answering session. So if you please, if you can hold on your questions for now until I finish, and then each time intermittently I'll maybe pause for a period where I will ask you if you have any questions so I can go on. Okay, so think we can start now. So I'm going to show you my screen now. So basically today's webinar is the best practices to design Automation Studio application for OPC integration. And from that, what we'll try to do, I'm going to pass over, I'm going to try to integrate an external PLC to an Automation Studio application by using the OPC Client interface. So basically our prerequisite to be able to do that are definitely the Automation Studio software. We should have an external PLC and programming software for the external PLC, an OPC server for the external PLC, and OPC test client. I will go on each one of these items one by one as we are going through the presentation. So I want to show you first of all my current setup, since we are not close to me. So what I'm now on my desk, I'm having the Automation Studio workstation where I have the program for the programming of the PLC is there, and I have Automation Studio, and we are connected. I'm connected over Ethernet LAN to my PLC. So basically, this is the application. I picked up a very simple application in Automation Studio where we're going to automate here a sequence on just a very simple pneumatic cylinder to just making A plus, A minus continuously as soon as I push the start button, and then stop it. When I stop, it will stop the sequence. So I'm going to show you the application. So intermittently, I'm going to just pause my PowerPoint for now, and I'll load Automation Studio. So Automation Studio is there. What I want to show you today, I'm just showing it over here. I'm loading first the application, as everybody knows how to do it and build it in Automation Studio. So I'm just showing you here the application. So what we have here the cylinder, and I'm having an Allen Bradley ladder logic used to do this simulation, this sequence. So I'm going to put it on, and then as soon as I'm running, you see I'm going to go back and forth. The ladder is executing, and then as soon as I'm pushing on the stop, everything will stop. So this is basically what we'll try to do during the next hour, show you how we can build this and make an external PLC do this sequence with this cylinder. So first of all, I'm going to just stop it. And then I'm going to start build the application in Automation Studio. So I'm going to start from scratch. So whichever things I'm doing over here, I'm assuming everybody did it 100 times in Automation Studio while they're doing their demonstration or using it. So I'm going to start a new project. And here I'm going to use the default template. So here I'm going to put my zoom to make it clear. Now I'm going to go and from the pneumatic library start putting my symbols. So I'm going to use a double acting cylinder. Then I'm going to use here, I can use a distributor. So I'm going to select a distributor, a directional valve, 5.2, good enough for me. I'm going to take it. Now definitely this valve's not going to work as it is. Okay. Here I'm going to just modify it with the builder. I'm going to change this to a solenoid. Here. So I have my valve ready. Now I'm going to do my connections. And then I'm going to put the air, put here air and 2 exhausts. And then I'm going to use my HMI library to just build my buttons. So I'm going to use control buttons. So I'm going to eliminate the push buttons. I'm going to take here, I'm going to say that this is my start push button. I'm going to do the same for stop push button. Let me change the color on this one. So I'm going to make this one green. And I'm going to use a light, a pilot light. Let's say blinking light, probably better. So I'm going to put it here. And this light, I'm going to use it just to say that the cycle is ongoing. The sequence is on. I'm going to change it. And then let's say I'm going to put it in blue color. To fancy it a little bit, I'm just going to make a box around it. Then change color and change lines. So that's basically my Automation Studio application. Yeah, I'm still missing, proximity sensors. So I'm going to go to pneumatic. I'm going to take on the sensor side, proximity sensors. So I'm going to select here. This I'm going to say, I'm going to call this one prox A+, for example. And here I'm going to move my cylinder to the end. Oops, and I'm going to use another one for the prox for the A- position. Let's put it back the way it was. Now this is my application. I want to come back again here. So to my presentation, my PowerPoint. So basically, this is what I got. Now, if I want to start doing this to make it ready for OPC, a very good way of doing it and very good for documentation is to start associating my input and output and define them into the system. So here I have to start create internal variable in Automation Studio, and I'll tell you why I'm using internal variable to associate them with devices later on. So here, to do that, I'm going to get back again to my application. There is several ways where you can do it. Well, the normal way of doing these things is just like you can select the prox, for example, and then on the variable assignment, that's what I want to do. I'm just going to create a variable. So I'm going to define it as a Boolean because it's a Boolean signal coming out of there, and I want to give it a name, this variable. So I suggest to use inputs starting with I underscore and give it a name, prox A plus. And then after doing that, I can just here start to do the linkage between the prox, the variable with the internal value pros1. This is one way of doing it. I really suggest to, because the points can be tremendous, and I'm going to be needing another way also. I'm having the OPC part where I have to link OPC variables or items, sorry, to the Automation Studio variables. So what I did, and I can share it with you at the end, is an Excel sheet where we define all these points on it and then automate the entire process for doing the linkage. So I'm going to go over that with you now. Basically, this Excel sheet, I standard put it into, let's say I'm going to open here. It is standardly located on my side, and this is something I figure out that's very good to have it into the C drive under Program Data, FAMIC Technology, and create a folder called OPC, and then the content of this folder, I can share it with you later on. It contains scripts, APIs, which can be used to automate the entire process. So I'm going to have here in the subdirectory OPC tags a file in Excel, and I selected Excel as a tool because Excel is very useful and very used by a lot of people in the industry while they do programming. So this Excel sheet consists of several folders. So I'm going to speak about the other folder one by one as I'm going through the presentation. So I'm having a folder called OPC item, and this is in this folder I want to start defining my input and my output variables that I'm going to be using build around at my project. So we started by putting the iProx A+. This has been already defined, so I'm going to start with the next one. So, or let me put it anyway. I'm going to put it. I have So first of all, let's create space for some input. So I'm going to just create here some rows, and then I'm going to just create here the names. So I'm having prox A plus, control V, this one will be minus. The minus for the other one, the minus. I have here this are inputs. Now I have also a start button. So I'm gonna create the start and the stop. And for the output, I like to start naming my output by O underscore, and then I give the name of my output. So I'm having here two outputs, so the solenoid A plus and A minus. And then also I'm going to create one for the pilot light. I'm going to call cycle on. So for this, I start to just to complete this because I have to fill it in a certain way, and I documented these things in a procedure. So I'm just going to copy for the input, and for the output, I'm going to copy here for this for the output, paste, and here I'm going to take this line I don't need. I'm going to delete it, and this is basically I'm going to start like that by defining here the input and the output for this simple AS diagram. Now the other things to complete this, we have to recall that whenever we define a variable in Automation Studio, we have to tell what data type it is. So they are all Boolean, so I'm going to copy here Boolean. And they're all located, I want to locate them at the project level, so I put the location, the dot. Dot means in Automation Studio that it's at the project level. I want to create this variable. And I'm going to use a start value for this as false. Once I did that with my Excel sheet, I can just import this variable into Automation Studio, and this way everything going to be defined properly in the project. So first of all, to not mix things up, so I want to first goes on my variable manager, and I want to delete the variable that I created, which is this one here. I want to delete it. So this is the one I created manually. And I can just now, if I go back to my spreadsheet, I created a macro. So here the macro to do it, my file, I'm going to do quote, comma, export. I'm going to run it. And it will ask me where to put my import file. So I can put it anywhere in my workspace on the computer. I'm going to put it here in the same place where I have my Excel sheet here, OPC tags, and I'm called it, let's say, PLC IO CSV. It's gonna create it in CSV format. And now once the file is created, I can come over here in the variable manager and import the variable in Automation Studio. And then I'm gonna, it's here at FAMIC Technology OPC tags, PLC IO. I just open it. And now I have my variable you see over here in the variable manager. They all have been imported. Okay. Now, once I define my variable in Automation Studio, I can start do the linkage with the devices. So what we do here, I'm just going to come back here. I'm going to tie in, as I said, all the input are I underscore. So here, this is the prox A, so plus, so I'm going to tie it with A plus. Now the A minus is going to be A minus. Now I'm going to take, I still have my start and stop, so I'm going to take my start button, turn a link, I'm going to take here I, so this is my start, and here this is my stop. So I connected all the inputs, tied them to the devices, all the inputs in the project. Now I'm going to start do the same for the output. So I'm going to come over here. I'm going to start with the variable assignment on my solenoid. And here I'm going to put the output, which are O underscore. So this solenoid is going to push the cylinder this way. This way is going to do move, is going to push, okay, let's say this way, this is the A plus, this one is going to be the A minus, so this one is the A minus, and this one is the A plus, right? And the last one here is my pilot light, which is going to be tied in to cycle on. Now once I did this, very simple, I can just verify that everything is connected properly. So in the variable manager, I want to put these things over here. So if I go in simulation mode, you'll find right away that my prox A plus is on. So the variable I, which is I prox A plus, is checked. That means it's true. Now what I can do, I can start moving my solenoid. So for example, if I want to move it on the other side, the A minus, I'm going to force the A minus. So you see right away on the diagram, it moves to A minus, and the A minus solenoid is on. Then if I do the A plus, goes on the other direction, and the same thing I can check on the start. Clicking on the start, my variable changes here to true. The stop, same thing. And the cycle on, if I just turn it, it blinks. So all my connections are done properly, and now everything is ready for me to do the programming in the PLC. So next step, after doing that, I have my project. I said Automation Studio is ready. So if I come back to my slides over here, so these are my variables are very well defined. So the next step is to start writing the sequence in the COIO ladder diagram using the Click programming software. I'm not going to do this. I already have the program ready for you. So basically what you see over here, as you do any PLC programming, you have to assign for each variable, input variable, an internal register to define the register that's going to be used in the PLC. And here I'm using internal register and not directly input and output. And I'll say this at the end of why I'm using internal register later on at the end of my presentation. So bear with me. We're going to be using internal register to assign to input and output. So here for this specific PLC, and depend on the type of PLC that you're using or your customer is using, we have to know the addressing, how to address internal registers. For the COIO PLC, the internal registers are named, they start with C, and then they are enumerated 1, 2, 3, 4, 5, 6, 7. So here I'm going to select 7 consecutive registers to be used for my input and my outputs. Now, after that, to reflect this, I have to reflect it on my spreadsheet over here, and I can use this later on for programming and for documentation. So you see here what's nice about Excel is that I can just drag and get the registers, and from there I can start doing my PLC program. The PLC program, I have here the PLC program. I already wrote it, so I'm going to start open existing project. So here, this is the program. This is the sequence we had previously in Automation Studio, and we wrote with the Allen Bradley library. And this represents the sequencing A plus, A minus as soon as I'm hitting the start button. And then when I hit the stop at the end, I can stop it and stop the cylinder from moving. Now, before going on to, let's say, downloading into the PLC, I can stop now briefly for a short period of question. If you have any question, please raise it now. So before going into the PLC side, does anybody had any question? I see Christian, he raised his hand. Okay, I'm going to try to put Christian on the microphone. So here, yes, Christian, you can speak now.
Can you hear me? Okay.
Yes, yes.
Sorry about that time. George, I was wondering something. At the beginning when you were opening your Excel sheet, you mentioned something about a macro. Does that macro becomes available to customers, or how do they have access to this?
Well, basically, the Excel can be used by us as a toolkit to give to the customer. The thing of using the macro to generate the CSV file to import it into Automation Studio, he can use his own way of doing this CSV file. Excel is one way of doing it, so that's why I used Excel for it, because a lot of people are using it. But sure, we can share it and make it available, because the same Excel sheet, as I'll show you later on, will be used to do the assigning and the tying OPC items with Automation Studio variables. So
Okay.
that we can share, yes, with the customer base.
So basically, you are using Excel because you want to use Excel, but they could actually do it without using Excel. Is that what you're saying?
Yes, they can. Well, by the way, when I showed you at the beginning, I showed you a way of doing it manually. You can define it one by one, but
Okay.
I didn't want to repeat the punching, because I'm going to be using, I'm still going to be using Excel later on to automate the process of tying in OPC items to Automation Studio variable. Although I'll show you also the manual way of doing it, but it's more handy as specifically for project to clients when they have hundreds of input and outputs to do it in Excel than doing it one by one in a project. So and this Excel sheet also can be used for documentation of the project. So it can be used for several things. So that's why I use Excel, because it's used a lot by people in the industry to document their stuff.
Okay, and second question, when you created the schematic in Automation Studio, you actually link these variables to other variables that you created, like with the I for inputs and O for outputs.
Right.
But if we use virtual systems that are already made in Automation Studio, which all the variables are already available for customers, do they still need to have like a middle variable to connect to, or they can actually connect directly to the variable of the virtual system?
Well, for virtual system, the reason why I'm using this intermediate variable is to make the system cleaner in later on. Once you're going to be writing, for example, if you do, for example, SFC graph set, instead of using these internal variables, which sometimes you may forget about they belong to which device in the system. By tying it in at the beginning with this intermediate variable which carry a name that makes sense, you'll find your SFC self-documentable later on once you read it, and you'll understand exactly what's going on in the system. So I recommend that you use, yes, this variable for the other variable, unless at the beginning, if you design your virtual system, if you design it so that the variable that are interfaced to the other system being written in this kind of standard, by all means, do it this way, because it's going to make a lot of sense later on if you write your logic to understand what's going on into the virtual system.
Okay, thank you.
Okay, so I'm going to continue now with the downloading. So we have here the program. Now, to do the download, each specific program for PLC has a way of downloading the program to the PLC. So here, in this one, I'll write the project into the PLC. So it detected the PLC. It's connected to this IP address. So I say connect, yes. And then after this, I go on to do the downloading of the program. Now the program is downloaded into the PLC, so it's ready in the PLC. Now the next step, after downloading this to the PLC, what we want to do next is this. We want to make, let me put it here. I want to put it. So basically we need the PLC to communicate with the Automation Studio application. So basically what we want to do that. First of all, by doing this communication, we want to exchange the variable between Automation Studio and the PLC. So basically we want to send the value in the inputs into the internal register C1 to C4. Then once it's in C1 and C4 in the PLC constantly execute the ladder logic. And then once it's executing the ladder logic, it will define the value that the output has to be, which are C5 to C7. Now what we want to do, we want to send this variable into Automation Studio to the internal variable, and then we close the loop, and this process happens very fast, that at the end it makes us feel that the program, the logic is running in Automation Studio, but really the logic here is running into the PLC, and the system here in Automation Studio start moving in simulation mode. Now, so our next step is we want to connect the PLC register to Automation Studio variable. And how are we going to do that? We're going to use OPC. Now, what is OPC? OPC is a technology that Microsoft developed with all the PLC and electrical control manufacturer in the industry to enable communication with PLC and all automation devices in the world. So basically it's an international standard. And I don't want to go through the detail, the protocol itself, but I want to show you basically how it works. So basically in this OPC technology, I'm showing you here, we have the Automation Studio computer, which is the workstation which has the Automation Studio application. What we use what we call an OPC server. And this is a piece of software that anybody can do. Anybody can, Kepware, for example, is a software that I'm using here in this example, is a company that specializes in writing OPC servers, and it writes it for all sorts of PLCs. Also, the manufacturer of the PLCs can provide you with their own OPC server. So what this software do, it runs in the same machine as Automation Studio. Once you put it, and then this software will guarantee and do the protocol and communication with the PLC to exchange the variables. Then on the side of Automation Studio, what they did over here, the development team, they developed an embedded OPC client, which is a piece of software that they add in Automation Studio, and we call it the Automation Studio OPC Client Interface. This piece of software, this layer of software in Automation Studio connects to the OPC server, and for this connection guarantee the exchange of the variables between the PLC and Automation Studio, and we can close the loop and make the two communicate together. Now, in the OPC standard, there is also other products which we call the OPC Client, and a generic OPC Client is an application which contain only the means to communicate with the OPC server just to test it and to see if everything has been set properly to be able to let other applications communicate with the OPC server and validate the configuration of the OPC server. So this is what we're going to do now. So I want to show you how we configure a Kepware server to be able to communicate with Automation Studio. So I'm going to stop my PowerPoint for now and go back here. So Kepware, as I said, is a software that you buy, and you may download it from Kepware. If you go on the internet, Kepware, you'll be able to download their OPC server for evaluation. And what's nice about it, it gives you 2-hour evaluation period, and then where you can test the OPC server. And then what's happening, once the 2 hours are elapsed, you can restart it again and you get another 2 hours. So it's good enough to demonstrate OPC with it in Automation Studio, just for the purpose of demonstration. Okay, so once I installed already Kepware on this machine, and once you install it, I'm going to click here. You have the configurator of the OPC server, and it comes like this. This is basically the configuration window for Kepware server. So you see over here on this side, a project consists of several things. The server can do a lot of things. So I'm worried this really, I don't want to go through the details about the different options. This you can get through documentation of Kepware, but for the case of this demonstration now, you have this branch called connectivity. I have to start defining the connectivity branch. Connectivity branch, here I start first by creating a channel, and a channel, basically I define how I'm going to communicate with my PLC. And this part is specific to each kind of PLC, and you get it through documentation of the PLC. And usually people doing automation, they know they can, there is a chapter in the manual of the PLC telling how you can communicate externally with this PLC. So if you look over here, they're defining the channel, it offers me what kind of PLC I'm going to be using. So you see over here in this drop list, there is a whole bunch of them. The one I have here on my desk is Koyo. So if I go on K, it's not there. But I don't have to worry much because Koyo is still a standard PLC in the industry. So it communicates with a standard protocol called Modbus. And the way it communicates is using Modbus TCP Ethernet. Well, these details are really written in the manual of the PLC. So Modbus TCP is the way that we're going to communicate with. Now the next thing after that, we give this channel a name, because the name is very important in defining the address of the register that we're going to communicate with in Automation Studio. So in my case, I will call it AS Modbus, and then you can name it anything that may appeal to you or contextual to your project. So AS Modbus is a name. Now we can continue going on through the wizard of configuring the channel, and usually all the default value are good enough. So the only thing that we have to worry about here is just to define the network adapter, which is the network card on the computer that will communicate with this PLC. Some station have more than one network card. The industrial workstation, they can have more than one internet card. So here I will select the one which is, I know it's, I don't use the default. I'll select specifically this one, which is the network card of the LAN where I am communicating with. Okay, so I select this one, and then I can move on with the default value until I go and finish everything. Now, once I define the channel, now I can communicate by Modbus TCP with several PLCs. It's not only one. It can be like on the standard, hundreds of them I can communicate with. So here I have to give a name to the PLC that I want to talk to. So this comes adding a device. So I add the device. It gives it a default name, device 1. So I'm going to call it PLC 1. Next. And then I go on here. I select it's a Modbus PLC. And then here I enter the IP address of the PLC. And this is very important. I use fixed addresses, which is, this is the address of the PLC. And then you find here, give you .0. Here I leave it like it is. In Modbus protocol, this is the detail about the protocol. You on a PLC, it can have more than one card or deported IOs where, you know, like they all concentrate into the PLC. So for example, if I wanted to communicate with cards on this PLC attached to it, so here comes where I have to define 01, 02, 03, so sorry, 0.20, 0.1, 0.2, 0.3. But in my case, I have only one PLC that has local IOs, so 0 is the PLC, okay? So I go next and continue until everything is done for me. So I have now everything set in the configuration of Kepware as a server. Now the next thing is very important. I have to start communicate with the PLC to see, to test the communication if it's right, if what I did is good or not good. So basically, you start using the test client. So I'm going to launch here a test client. The test client, by the way, the OPC Quick Client, it's a software that is given also by Kepware. And usually, manufacturer of OPC Server, they give you the OPC Client to be used to test the configuration. So this comes with Kepware software. So the first things you have to do in OPC, and this is based on OPC standard, is to do a connection with the server, to connect with the server. So to do a connection, I click on this point here at this button. Then I select here Kepware, because on my machine, you see over here, there's more than one OPC server installed on my machine. So I want to use Kepware OPC server, so I select Kepware. Now the next thing is I create a group, and a group in OPC is a collection of items that will be scanned at a certain frequency. So I can have more than one group. I can scan fast inputs in a rate of 100 millisecond or 10 millisecond if I wish this to get the communication fast, or I can scan slower, for example, thermocouples, if I want to measure temperature at slower rates, like 30 seconds or a minute. Usually temperature doesn't vary much in a system. So here I'm going to use the default value because I don't care. I'm testing here just the to configuration. So I'm having here, I'm going to give it a name. I'm going to call it, for example, test. And it's by default 1000 millisecond. That's one, it will scan at 1 second frequency. Now after this, I come over to defining the items, which are the points that I want to read or write into the PLC. So you see over here, notice that once I go into here, it gives me a browser and it shows me the stuff that exists on the branch that I did the configuration on with Kepware. And it gave me this information because it's already has a connection. It connected. So there is a connection with the OPC server. So this information is available for me. So you remember here, the channel is AS Modbus and the PLC is PLC1. So I navigate this to AS Modbus and PLC1. And then from there, I can select any variable. And I can take this for purpose of syntax. I need it, so I can copy it. I'm going to open here Notepad. I just want to examine the syntax, what's written. So you see here in the syntax, what I really need to do is, I don't need this part. I need this section of the syntax to address the PLC. And on this side, after the point, I enter the register address where I want to communicate with in the PLC. Now come the next point into the equation. What is the address of the PLC register? So normally, if in Koyo was one PLC defined in the Kepware server, I could have written here immediately C1 because I know the register, the internal register as C1, C2. But because it's not there, and I said it's a Modbus device, I have to write here the equivalent address in Modbus for C1. So this part, don't have to worry much about it because the manual of the PLC gave it to me. So in my case, I can find it over here with this interface. If I look over here, there is address picker. You see, I want the address, for example, of the C1 register. So C1, this is the address in the memory of the PLC. You'll see over here, display Modbus address. So if I click on it, it gives me the address, which is, you see over here, 16.385. So this is the address I'm talking about. I have to put in this line. So you do here, the format has to, in Modbus, has to start with a 0, and I write 16.385. Okay, so this is my address for the item. I copy here, and then I just eliminate this one and just paste it here. And then I can check to see if everything's fine. You see, it recognizes that it's a Boolean variable, which it is. And now if I click on OK, you see right away that I get a linkage and I see a value, which is a value of 1. And it's very important for me to make sure that everything has been properly configured is the quality. And the quality is good. If quality is bad, it means that I did something wrong. It's either the PLC is not running or addresses. I have to look at the addresses for the PLC and look at the configuration to find out what's going on, why I have a bad quality. But good mean everything is fine. So that's everything is connected and properly configured in the OPC side. The next part is to start doing the assignments in Automation Studio to make everything to correspond to each other. You know, like I just want to tie up internal variable in Automation Studio with OPC items. So let's keep this in mind, this address. This is C1. I have it here, still written it here at my notepad. So here I can for now, I can create some space. I'm going to take it out. I'm going to minimize my window here. And OPC also I can minimize. I'll go here. I'll stop. Now, what I'll do in Automation Studio, I have in the tool ribbon, I have the communication manager. So from there, I have to start create the linkage, go through the same process I did with the OPC client, but inside Automation Studio, because as I said, Automation Studio contains the layer of OPC client, the embedded OPC client. So I have to first create a linkage to the OPC server. So here I go open the OPC client here, and then right click, add an OPC server. So I go here, I add the OPC server, Kepware. So as soon as I add it, you see here the connection is done right. I get it in green. And then I create a group, add an OPC group. So usually take the default value is good enough. Group 1 is good. And then on the linkage, I select group 1. I want to associate items to group 1. And here, remember I told you that I'm going to name my input with I underscore. So you see here, I'm going to start taking my prox A+, which is a C1. Remember here in my spreadsheet, prox A+, I said that this is C1, okay? So I'm going to take A+, and on this part here, this side here, which is the OPC item definition, I'm going to paste the address that I knew the syntax of. So this is the relation between, well, this is how I tie in the OPC item C1 to this internal register in Automation Studio. Now the next details I have to worry about here is it an input or an output? And there is a difference, because an input point in Automation Studio, it's a point that generates a one that's going to be written into the PLC. So from there, you come over this section where I have to define in which direction the variable going to write. So here, this first one is the PLC. OPC, it means the PLC device or the OPC device going to write into the register. So this is not my case. This is an input. It's Automation Studio that's going to write into the PLC. So I select here X to OPC. And from there, I can just connect. So here I linked my register in OPC, in the PLC, with the register in Automation Studio. Now you see over these things, this process, I'll have to do it one by one for all the points I created. So that's why to automate this process, to make it easier on the user, I created the PLC, the Excel sheet. So in this case, I have to complete this Excel sheet to prepare it so I can do this linkage in a macro to be faster. And here the macro is going to be run in Automation Studio. It's an API. We have already the API in Automation Studio that will do this process automatically in a script. So remember here what I said. We have C1. I'll put here, I'm going to paste here the address. I'm going to paste again here, but this one is the next one. So the next one is 6. So what's nice about Excel is that once I created 2 addresses consecutively, I can create everything. Now, everything is defined in Excel. I can save, right? It's saved now. And then in here, I will take it out because this is the manual way of doing it. I don't want to do it manual. I want to do it automatic. So I'll remove my OPC group. I'll delete my OPC server, right? And then something to use the APIs of Automation Studio, there is a script to have this ribbon, OPC ribbon. You have to run it in the initialization script, and this is something I can share with you. I can give you the script that do this. So in my case, when in the startup here, you see here there's a startup script. This you have to add if you want to have this ribbon. So this is the name of the script I'm using. So I can give it to you later on. So it starts and it creates for me this ribbon. So here, what I'll do, I'll just click on OPC item linking, and then you see everything is done now. I have the OPC items variable linking completed. I can check it out. Very simple. Got my communication manager. So you see over here right away, I have the connection with the server. I have my group, and all my points here are defined. So you see, it's easier doing it with a script, especially if you have hundreds of points or more than that. So this can do it. Now the only thing I want to, if you decide to do it manually, I want to specify here that for the output, I mentioned that for the input, whenever you do the linkage, you select this type of connection, which is the X, which is Automation Studio writing in the PLC, OPC. For the output is the reverse. It's basically the PLC that will generate a value that has to be written in Automation Studio. So you select this type of linkage. So you see here the access, it's OPC writing into X, and you see here it shows in the access column. This one are this type. This one is the other type. So that's basically it. Now I'm ready to test my PLC program. So let's test it, see how it's going to work. So you see now, I have my PLC running the logic. I can show it over here. And this is my Automation Studio project. So you see here the status of the register, and this is everything is running now. Okay, so is there any question? Now I'm opening the discussion for the next period of question asking into this seminar or webinar. So does anybody have any question? Okay, so Christian again. Yes, sir.
Hi, George. Can you hear me?
Yes, I can hear you.
Can you hear me? Yeah, okay.
Yes.
Okay, well, I'm not the specialist in automation. For me, it seems a bit complicated to, I imagine a teacher in class having to explain all this to the students in order to have them test their PLC programming with Automation Studio. So because as from what I think, correct me if I'm wrong, but right now, if a student has a PLC, it's Allen Bradley, attached to a little system, he's just going to write in his input and output right in the system, upload and test right away. He doesn't have to do all these, back and forth. So I was wondering, can we supply to the end user, let's say a file for Allen Bradley, Siemens, or a couple of major brands of PLC that would have all this setup already made. So when the students actually open his RS Logic, for example, for Allen Bradley, all the links already made to Automation Studio, so he only has to write the logic in the PLC and then run and test it right away. Can that be done?
Yeah, sure. Like what I'm showing over here is not intended to be done by the student unless they can do it if they wish to do it. But it seems complicated, yes. Do the student has to do it himself? I don't think so. It's the job of the teacher that he can, for example, prepare exercises where he can just like do the tie-in, directly of the Automation Studio variable to PLC addresses, and the student, what he needs to do is just like know exactly what are the addresses in the PLC that represent the I/O, and then use it to do his programming and test the logic. So I think this is the way to go. And what we can do for the virtual system, we can provide our customers an OPC version where specifically to a specific PLC, we do in the tie-in ourselves and do the configuration, but they have, on the other side, they have to use the OPC server that we specify, and from there, like it can be done easier for the user to use it, more user-friendly than building it themselves. But what I'm showed over here is the steps that it takes to do. They seems to be complicated, but I think if you do it once, it's simple enough. Like I went slowly to do it, but usually you can build it fast if you do it once on your own.
So basically what you're saying is that, let's say if we create a virtual system, and on that virtual system we could have a little image on the right side, let's say saying that this variable in AS will be this variable in Allen Bradley, for example. So they have the table of equivalents, and then we supply this file. We say that we use the Capeware OPC server that is free, so they can download that. And providing this, the students would open and just have to write the logic in the PLC to control Automation Studio.
Exactly. That's what.
Okay, great.
That's the way to do it. Yeah.
Okay, thanks.
I don't think that anybody is asking for questions, but I'm available in case you need anything. You can call me in Montreal, and I can answer all your questions and spend the time to elaborate more on your question and go further in other examples.
Yeah.
So, okay, everybody, thank you very much for your attention this morning, and hope that whichever things I exposed for you is useful. So talk to you on another webinar soon. Thank you very much.